In this tutorial, we are going to simplify rational expressions. But before we simplify these four rational expressions here, let us simplify first a simple fraction. Let us say we want to simplify 8 over 12. First step is to factor both numerator and denominator. When we factor, we have to make sure that we are using prime factors. So the factors of 8 are 2 times 2 times 2. And the factors of 12 are 2 times 2 times 3. Now, the reason why we want prime factors is that when we cancel, after we cancel all the common factors, like a pair of 2's and another pair of 2's, the leftover will represent the simplest form. So we're going to factor these rational expressions in the same manner. We're going to factor both numerator and denominator, making sure that the factors are prime or cannot be broken down anymore. And then we cancel common factors. So let's start with the first one. We can factor 20 as 2 times 2 times 5. Now, b to the fifth, I will not expand it. I'll just keep it as b to the fifth and c cubed. For the denominator, I'll have 2 times 2 times 2 and b to the second and c to the seventh. Now that I see clearly what the factors are, I can now cancel common factors. So I notice that I can cancel a pair of 2's and another pair of 2's, and so we have 5 over 2 left. And then for the b's, I can cancel a couple of b's from the denominator, and I will do the same thing from the numerator. So out of the 5 b's in the numerator, there will be 3 left after I cancel 2 b's. Now for the c's, I can take out 3 c's from the top. I'll do the same thing from the bottom. So out of the 7, there will be 4 c's left. So now the leftovers are 5 from the numerator, 2 from the denominator, b cubed from the numerator, and c to the fourth from the denominator. There's the simplest form. Now for the second expression, we recognize that 3 is a common factor of the two terms in the numerator. So we can factor out 3. So we'll have here 3 times x minus 4. For the bottom, we could factor out 4. And so we'll have 4 minus x inside the parentheses. However, we see that the factors are not exactly the same. So we cannot cancel if they're not exactly the same. However, we can fix this. I can either fix the numerator or the denominator. I'm choosing to fix the denominator. So in the denominator, instead of having positive 4 outside of the parentheses, I'm going to put a negative 4 instead. And because I changed the outside, then I'll have to change also the expression inside the parentheses. So the 4 should be negative 4. And the negative x will change to positive x. So that when I multiply this expression, this new denominator, it will be the same as the product of this denominator here. All right, so now I'll put the numerator, and we notice that the factors are exactly the same, and so it's possible for us to cancel. And the result, or the leftover, is negative 3 over 4. This is the simplest form. Now, the third one, for the numerator, we can factor out x squared. We can factor out x, but we should factor out the greatest common factor. So therefore, we should factor out x squared. And so inside the parentheses, we'll have x minus 5. The denominator is a difference of two squares. 25 is a perfect square minus x squared is a perfect square. So we're factoring a difference of two squares. So we'll have here 5 minus x and 5 plus x. Again, we notice that none of the factors are exactly alike. So we'll see if we can fix it. And we can fix the top so that the factors will look like the ones at the bottom. So instead of having a positive x squared on the outside of the parentheses, I'll put a negative x squared. And so we'll have to change the expression inside the parentheses. So instead of x, it'll become negative x, and instead of negative 5, it'll become positive 5. Then we write the denominator, 5 minus x times 5 plus x. Now we can cancel 5 minus x. Therefore, the final answer is negative x squared over 5 plus x. This is much simpler than the given. Okay, last one. The numerator is another difference of two squares, so we can factor this as 2x plus 1, 2x minus 1. The denominator, which is a quadratic trinomial, we can factor this using the box. So I can think of this trinomial as the area of a rectangle. 4x squared goes here and negative 3 goes here. For the missing spaces, we know that the product will be negative 12x squared, and the sum of the missing spaces will give me negative 4x. So I have to think of two numbers that when multiplied gives me negative 12x squared, but when added will give me negative 4x. And that's going to be negative 6x and positive 2x. That's going to be negative 6x times 2x is negative 12x squared, and negative 6x plus 2x is negative 4x. So we know that these missing numbers here in the box are negative 6x and 2x. And so we need to figure out the length and the width of the rectangle. So in the first column, they have a common factor of 2x. And so now 2x times something equals 4x squared. So I know it's going to be 2x on this side. And then 2x times something is equal to negative 6x. So I know this is going to be negative 3. And then now 2x times something equals 2x. And that's going to be positive 1. So therefore, the factors of the denominator are 2x minus 3 times 2x plus 1. So now we notice that we can cancel 2x plus 1. And so the leftover will be 2x minus 1 over 2x minus 3. And this is the simplest form.